All right, good afternoon, everyone. Welcome back. Before we begin our presentations today for Module 4, we will continue with where we left off in Module 3 with the review of Quiz 3. Just to remind everyone, we are recording this module, so please do try and keep your microphones muted. So let's get right into the review. We will go right to question number 4. Which one of the following is not a green infrastructure BMP? And the correct answer here is D, an extended detention basin. These are found in Chapter 11 of the BMP manual, and they are not considered to be green infrastructure. Small-scale bioretention basins, vegetative filter strips, and pervious paving systems are all green infrastructure BMPs, and they're all found in Chapter 9 and Table 5.1 of the BMP manual. Question 5. When reviewing water quantity calculations, which of the following must the reviewer check for accuracy? And the correct answer here is D, all of the above. So these are various things you need to check, and land covers, basin design, and hydrographs must all be checked for accuracy in a site review for water quantity. Question 6. Which of the following conditions must be met when a stormwater BMP is allowed to infiltrate the entire runoff from the 2, 10, or 100-year storm? And the answer is D, all of the above. Infiltration of the entire 2, 10, or 100-year storm is allowed only when the existing site conditions are such that no runoff leaves the site for the pre-construction condition scenario, thereby constraining the design to infiltrate 100% of the volume produced by the post-construction condition for the same design storm. The maximum storm that can be entirely infiltrated is the largest storm event only if no runoff is leaving the site in the pre-construction condition. So for example, if there's no runoff from the pre-construction 10-year storm, but there is for the 100-year storm, then for the proposed condition, the maximum design storm that can be fully infiltrated is the 10-year storm. And the answers for B and C paraphrase what is found in the rules. Only small-scale BMPs can be used to infiltrate runoff of a storm larger than the water quality design storm, unless required by another rule or agency. And soil testing of saturated hydraulic conductivity must be performed strictly following Chapter 12 of the BMP manual. Question 7. What is required as part of the municipal stormwater management plan to grant variances or exemptions from the design and performance standards? And the answer here is C, a mitigation plan. A municipality must have an approved mitigation plan as part of its municipal stormwater management plan to grant variances or exemptions from the design and performance standards. Question 8. If you have an impervious surface that has existed for 10 years, but have removed this impervious surface prior to the submission of the application that includes a stormwater management review component, can you still use this impervious surface as an existing condition in the stormwater management calculations? And the answer here is B, no. We use the land cover that has the lowest runoff potential that existed on site in the past 5 years for the existing condition. If you remove impervious cover, anything you replace it with is going to have a lower curve number, regardless of when that impervious cover was removed. So impervious surfaces removed prior to the application cannot be counted as an existing condition. Question 9, true or false? If a project has been reviewed by the NJDEP Division of Watershed Protection and Restoration, the municipality does not have to review it for compliance with its Stormwater Control Ordinance, or RSIS. And the answer here is B, false. The municipality is required to review all projects that trigger their definition of major development, regardless of whether they have reviewed by the NJDEP Division of Watershed Protection and Restoration or any other regulatory agency. Remember, the municipality may have a slight difference in its definition of major development and can even be more strict than the definition in the stormwater management rules. Question 10, true or false? Reducing impervious surface on a redevelopment project always meets the water quantity control standard. And the answer here is B, false. So reducing impervious surface can help meet the quantity standard, but you would still need to be compliant with one of the 3 water quantity options. You would still have to demonstrate you meet the standard. Question 11, which of the following maintenance activities are not considered to be disturbance in accordance with NJAC 7:8-1.2? And the answer here is E, all of the above. So none of these activities are considered to be disturbance in the stormwater management rules that are effective January 20th of 2026. Question 12, true or false? Stormwater runoff from any new or reconstructed motor vehicle surface discharging into an existing or proposed stormwater conveyance system that ultimately discharges within a 300-foot riparian zone that's located within the same HUC 14 as the major development warrants a 95% TSS removal rate to address water quality. And the answer here is true. So in the previous rules, 95% TSS removal was required for stormwater that's discharged within a 300-foot riparian zone. But the NJ Pact rule is clarifying now that discharge into a stormwater conveyance system, existing or proposed, will ultimately discharge within a 300-foot riparian zone must also meet this 95% TSS removal rate requirement. Question 13. Currently, a 1/4 acre of a parking lot discharges to a CSO. Under the proposal, the parking lot will be resurfaced and the runoff from the surface will be redirected to the municipal stormwater system that directly discharges to a water body without any treatment. Is this activity subject to the water quality standard? And the answer here is yes. Peter did cover this in the stormwater runoff quality section of how to review a project part 1. So the runoff from the current parking surface is being treated by the sewage treatment plant. Although the parking lot is only being resurfaced and is not considered a disturbance, the redirection of the runoff to discharge to the water body will remove water quality treatment provided by the sewage treatment plant. Therefore, the activity results in a loss of water quality and requires treatment to a TSS removal rate equivalent to that provided by the sewage treatment plant. Question 14, true or false? The TSS removal rate requirement must be met on each subdrainage area of a site unless the discharge from each drainage area converges to a single discharge point on site. And the answer here is A, true. So you have to meet the standards for each drainage area, but also be aware that if runoff from drainage areas do converge on site, and no adverse environmental impacts would occur as a result of compliance with any one or more of the individual standards being determined utilizing a weighted average of the results achieved for that individual standard across the effective drainage areas. Question 15. Can an infiltration basin be designed with a perforated underdrain pipe as a means of discharging runoff from the basin? And the answer here is B, no. An infiltration BMP cannot have an underdrain pipe if it wants to meet the criteria for an infiltration basin in the BMP manual. Question 16. Which of the following BMPs cannot be used to meet the volumetric reduction standard at NJEC 7:8-5.6D1? And the answer here is C, a pervious paving system. Only the BMPs from Table 5.1 or Table 5.2 meets the volumetric reduction standard at 7:8-5.6D1. And excuse me, the answer is not pervious paving system. It is non-GI wet pond. So you please ignore the bold font on letter C. Question 17. When can a wet pond be considered to be a green infrastructure BMP? And the answer here is C. Both statements above must be met. In accordance with Note D to Tables 5.1, 2, and 3, only a wet pond designed to maintain at least a 10-foot wide area of native vegetation along at least 50% of the shoreline and include a stormwater runoff retention component that's designed to capture stormwater runoff for beneficial reuses, such as irrigation, can be considered a green infrastructure BMP in Table 5-2. Question 18. Which of the following would be exempt from the groundwater recharge standard? And the answer here is B, previously developed portions of a site in a designated center. Just being in planning area 1 is not an allowed exemption from the groundwater recharge standard, nor is redevelopment automatically exempt. Only previously developed portions of sites in the designated locations listed on this slide can be exempted. So that's it for the review of quiz number 3. Now let's continue on with our scheduled program for Module 4. And here's the agenda for the rest of the day. We will have presentations on groundwater mounding and additional NJ-PACT rule updates. Then we will get into a couple GI plan review examples before we get into our final quiz of the session. And before we dismiss you at the end of the day, we have a presentation of the updates to the MS4 program. With that said, please stand by while Peter Pliantos takes over to present our groundwater mounding presentation.
All right, thank you, Manesh. So yes, I will now share my screen. Okay. So good afternoon, everyone. Again, it's Peter Pliantos from the Municipal Stormwater Engineering Unit. In this presentation, we'll dive into the groundwater mounding analysis requirements and calculations necessary for the use of infiltration BMPs. This material is covered in depth in Chapter 13 of the BMP Manual. My goal with this presentation is to cover the requirements under the stormwater management rules, as well as concepts, methods of calculation, and examples, all in relation to groundwater mounding analysis. The rules require we assess the hydraulic impact of the proposed development on the groundwater table and design the site to avoid adverse impacts. Well, in order to describe what is an adverse impact, let's take a look at what happens when we infiltrate stormwater. Below the surface, the groundwater table rises locally, and then it needs some time to spread out before returning to stasis. When we force a concentrated amount into one area, we get mounding. This increase slows down the ability of the basin to infiltrate, so we can have problems if this increase is large enough to slow down the rate of infiltration beyond our 72-hour window, or from repeating the slowing down over and over, the basin can experience failure. Additionally, as this mounding spreads out, it can reach adjacent structures such as basements and septic systems. Let's look at a nice graphic that illustrates this. This illustration is in the paper prepared by Glenn Carlton from the United States Geological Society, or USGS. We have a house near an infiltration basin. The blue color area below everything is known as the saturated zone, whose top surface is the seasonal high water table. Imagine, if you will, that it rained. The rain has now stopped and runoff has collected in the basin. As stormwater infiltrates below the bottom of the basin, we get a temporary localized increase, or mounding, below the basin that is caused by stormwater infiltrating into the subsoils after the storm event. In order to dissipate, the volume of water under the curve has to move outward and downward until it returns to how it was before the rain. We need to calculate the maximum height of the mounding in order to assess the impact of infiltrating stormwater on the basin and on nearby structures. One method of calculating the height of groundwater mounding is covered in Chapter 13. That method, known as the Hand-Tush equation, dates back to 1967. It requires the computing capabilities such as that found in the Excel spreadsheet developed by the USGS. You basically enter in certain parameters and then click the Calculate button to see the results plotted. Additionally, the user gets results in the cells of a spreadsheet. Now, there are certain ground rules, pun intended, for using the spreadsheet. So we'll go over what parameters we need to define, and then we'll look at making sense of the plot the spreadsheet creates by virtue of a macro. This is a screenshot of the Hand-Tush spreadsheet. If you have used the spreadsheet in the past, you may find the spreadsheet a little bit different from the spreadsheet that was posted on the USGS website. That's because in March 2020, DEP published and adopted a new BMP manual chapter titled Chapter 13, Groundwater Table Hydraulic Impact Assessments for Infiltration BMPs, which provides both detailed guidance regarding the input values and examples illustrating how to conduct the groundwater mounding analysis. With permission from the USGS, we modified the spreadsheet. Here is how it looks today. All of the calculation algorithms are the same, but the units and the notes on the use of the inputs are modified to be consistent with other chapters of the BMP manual. Chapter 13 and this spreadsheet are available at the link shown on this slide. To get more familiar with the hand-touch spreadsheet, let's define the parameters listed here and establish the assumptions for their use in the spreadsheet. The first input parameter is the recharge rate. In the spreadsheet, you must use the design value for the vertical saturated soil hydraulic conductivity, which is 1/2 of the tested value of the vertical saturated soil hydraulic conductivity from soil testing performed in accordance with Chapter 12 of the BMP manual. The second input is the horizontal hydraulic conductivity, which is rarely tested on the scale of a single site just for the purpose of conducting a groundwater mounding analysis. Therefore, you will need to use presumptive values based on the site's location. If the site is located in the coastal plain, then the horizontal saturated soil hydraulic conductivity is presumed to be 5 times the recharge rate, that is, the vertical saturated soil hydraulic conductivity. If the site is located outside the coastal plain, the horizontal saturated soil hydraulic conductivity is presumed to be the same as the recharge rate. If you recall, Lisa provided us in Module 2 with the link to the Bureau of GIS website where you can determine if your site is in the coastal plain. That link is also found on this slide. The next parameter is the specific yield, which is the volume of water that will drain from a soil specimen due to gravity divided by the total volume of the soil specimen. Coarse soil will likely have a higher specific yield than fine-grained soil having the same porosity. Specific yield governs how much water the unsaturated zone can store when recharge reaches the water table. The more water that can be stored in the unsaturated zone, the lower the resulting mounding. Therefore, a soil having a higher specific yield may result in a lower mounding height than a soil having a lower specific yield when other inputs remain the same. For groundwater mounding purposes, specific yield is not calculated by subtracting field capacity from porosity. The hand-touch spreadsheet assumes that the BMP is rectangular in shape and the sides of the BMP are vertical. So we use the width and length of the bottom area of the BMP, also called the footprint. But since the mounding is highest at the center of the BMP, for graphing purposes, we use 1/2 of each dimension as the inputs for the length and width, which correspond to the X and Y axes respectively as the inputs. Now for BMPs that are not rectangular in shape, we have some additional guidance. For circular shaped BMPs, use the radius of the circular basin as both X and Y. For irregular shaped BMPs, convert the shape to a rectangular shape that has the same depth of stormwater runoff to be infiltrated and is best fitted to the original shape. And then if a BMP is designed with sloped sides, use the bottom footprint as the length and the width of the BMP and use the total volume of runoff to be infiltrated divided by the area of the bottom footprint to calculate the duration of infiltration period. And we'll define duration of infiltration period in just a couple slides. For the initial thickness of the saturated zone, unless proven by a field test showing the thickness of saturated zone beneath the proposed BMP, the default value is 10 feet. Note that the thickness of the saturated zone used in the hand-touch spreadsheet is not the thickness of a large regional aquifer. It is the distance from the seasonal high water table to the first hydraulically restricted layer. If a value greater than 10 feet is used, It must be accompanied by on-site testing results that demonstrates the value used is appropriate. The input value must never exceed 75 feet, which is based on the preliminary results of research conducted by the USGS. The exact maximum allowed value may be subject to revision based on the final results of the research. Any on-site boring used to justify a value greater than 10 feet must be a continuous sampling boring for the entire drilled depth. The duration of infiltration period, T, is equal to the time required for the BMP to drain the volume of stormwater runoff at the specified recharge rate, and is equal to the volume of runoff to be infiltrated divided by the product of the infiltration area and the recharge rate, where the volume of runoff to be infiltrated may be either the runoff volume produced by the water quality design storm or the volume of runoff to be discharged through exfiltration, if exfiltration of runoff during basing routing is used. The maximum duration of infiltration period that may be used in the hand-touch spreadsheet is 72 hours. When hydraulically restrictive soil layers are present below a proposed BMP, one solution may be soil replacement. Let's analyze how that may impact the input parameters. In the situation where the soil is replaced all the way down to the seasonal high water table, there are a couple of things to note. The recharge rate shall be 1/2 of the tested vertical hydraulic conductivity of the soil replacement media, up to a maximum of 10 inches per hour. However, the horizontal hydraulic conductivity shall be calculated based on the original soil, since the original soil will be surrounding the BMP outside of the soil replacement. The low permeability soil will still be present in the surrounding area, and the resulting horizontal hydraulic conductivity will still limit the ability of the runoff to be dissipated into the saturated zone and may result in high groundwater mounding in the unsaturated zone. Therefore, the use of soil replacement in basin designs must still be carefully evaluated with a groundwater mounding analysis. Example 7 in Chapter 13 of the BMP manual describes a groundwater mounding analysis scenario where soil is replaced down to the seasonal high water table below an infiltration BMP. And it is important to note, if a shallower depth of native soils is to be replaced, rather than replacing soil down to the seasonal high water table, the recharge rate shall be 1/2 of the lowest vertical saturated hydraulic conductivity of the remaining native soil. Continuing on, there are some important relationships between maximum mounding height and the input parameters to note. Delta H max is the maximum height of the mounding, and the value calculated by the hand-touch spreadsheet is that which occurs at the end of the duration of infiltration period. This is explained on page 17 of Chapter 13. However, the hand-touch spreadsheet does not further calculate the mounding as it spreads out over time, and we'll talk about this further in just a moment. A lower mounding height will happen when the horizontal hydraulic conductivity increases, the specific yield increases, or if the initial thickness of the saturated zone increases. You cannot just use the result from the spreadsheet as it appears. The results have to be checked against the physical constraints of the design. If you get a resulting mounding height that is higher than the distance between the basin bottom and the seasonal high water table, you do not get an artesian condition. It means the recharge rate is adversely impacted by a reduced hydraulic gradient and will be slower. That means you'll have to run the spreadsheet again after you make some changes. Because there is a proportionality between the recharge rate and the duration of infiltration, as shown in this equation, the changes include a smaller recharge rate and a correspondingly longer duration of infiltration for the same infiltration area and the same volume of runoff to be infiltrated. Furthermore, if the mounding height just touches the bottom surface of the BMP, the recharge rate will also be slower than the design value for the vertical saturated soil hydraulic conductivity. When this happens, you can stretch the duration of infiltration period while decreasing the recharge rate, or you can spread the volume of runoff to be infiltrated over a larger area. When opting to increase the footprint, you'll be able to use a shallower depth. As shown in the figure, the bottom surface means the top of the sand layer in the case of a surface infiltration basin. There are some limitations associated with how the hand-touch spreadsheet operates. The graph produced by the spreadsheet is comparable to a snapshot in time of the mounding that occurs at the end of the duration of infiltration period. Since it's a snapshot, it does not depict what happens over time, as the mounding height decays and spreads out. During decay, while the maximum mounding height under the center of the basin will reduce, the mounding will expand into the horizontal direction and potentially cause the tails of the mounding curve to rise higher than the height at the beginning of the decay. This means that if an underground structure appears to be above the mounding predicted by the spreadsheet or out of range of the mounding altogether, it may still be inundated when the mounding height decays, since the hand-touch spreadsheet does not provide the height of the tails of the mounding during the decay period. Therefore, caution should be used when applying the spreadsheet to analyze adverse impacts to subsurface structures in proximity to an infiltration BMP. Now that we better understand the inputs to the hand-touch spreadsheet and the results it provides, let's go to some examples that illustrate the method and what to do with the results. The examples presented today are two of the ones in Chapter 13 and are arranged from simplest to more complex. After a straightforward example, we'll look at an analysis that shows infiltration will be at a slower rate than the design saturated soil hydraulic conductivity and what changes need to be made because we encounter an impact. In other words, we'll see two different scenarios. For the first example, a major development located in the coastal plain proposes an infiltration basin whose bottom footprint measures 50 feet by 50 feet to infiltrate 5,000 cubic feet of runoff generated by the water quality design storm. The maximum depth of ponding water is designed to be 2 feet. Soil testing was performed in accordance with Chapter 12. The soil testing report shows that the seasonal high water table is 7.5 feet below the 6-inch thick bottom sand layer of the basin. The tested soil permeability rate of the most restrictive soil horizon below the basin is 4 inches per hour, and no nearby underground structures are present. So let's start with some basic calculations. Typically, the soil testing provides results in inches per hour, so the value for T would also use hours as the unit of measure. For the duration of infiltration period, We divide the volume of runoff to be infiltrated by the product of the infiltration area and the recharge rate. Also, remember that the recharge rate is 1/2 of the slowest tested saturated soil hydraulic conductivity rate from soil testing. Therefore, the duration of infiltration period is calculated to be 12 hours. When using the hand-touch spreadsheet, it is helpful to make a table of the inputs and the results, so they are ready to be added in later to the report. These inputs are organized to follow the order they appear in the hand-touch spreadsheet. The recharge rate is the first parameter entered into the hand-touch spreadsheet, but it needs to be converted to feet per day if you are using the older version. Feet per day is just inches per hour times 2, so here you would use 4 feet per day for R. The specific yield is set equal to the default value of 0.15. The horizontal hydraulic conductivity is equal to 5 times the recharge rate, since the infiltration basin is located in the coastal plain. And the basin measures 50 feet by 50 feet, so we would just input half of each of those dimensions since the analysis is performed at the center of the basin. And then the duration of infiltration period is obtained from step 1. We also need to divide hours by 24 to get the number of days, which is 0.5 for this example, if we're using the older spreadsheet. T is less than the upper limit of 3 days. And then the initial thickness of the saturated zone uses the default value of 10 feet. Alternatively, you can grab screenshots from the input section of the hand-touch spreadsheet, shown here with the parameter values from the previous slide entered into the gold shaded cells. This version of the spreadsheet is one that allows time to be input in hours rather than days and recharge in inches per hour. With the inputs entered, I clicked the dark blue Recalculate Now button and took this screenshot after the macro finished plotting the blue curve. The results show in the red cell in row 16 the maximum height of groundwater mounding, represented by the variable delta H max equals 6.07 feet, which I have circled in light blue. And this is what will occur at the end of the duration of infiltration period. To put this into proper context, I've also superimposed a symbol representing 1/2 of the bottom surface of the basin. Since the seasonal high water table, which the spreadsheet always sets at y equals 0, is 7.5 feet below the bottom of the sand layer, the temporarily elevated groundwater table, located at y equals 6.07 feet at the center of the basin where x equals 0, will not reach the bottom surface of the sand layer. Therefore, the assessment shows no adverse hydraulic impact to the proposed infiltration BMP from the groundwater mounding. Remember that had the height of the mounding been high enough to intersect the bottom surface of the basin, it would mean the mounding will interfere with the infiltration capability of the basin. We would have to run a new model or trial that would involve increasing the basin footprint to spread out the volume of the stormwater being infiltrated. That would result in a lower depth of stormwater runoff in the basin since the volume is the same, and the duration of infiltration period would have to be recalculated before the spreadsheet is run again with these new parameter values. If you recall the duration of infiltration period equation from a few slides ago, the footprint area is in the denominator. So we would see the duration of infiltration period decrease proportionally as the area increases. Next, let's talk about when things go wrong. meaning adverse impacts. This slide is not for the example I just presented. It is meant to show you what happens in the spreadsheet when the groundwater mounding height is too high. If you click on the dark blue Recalculate Now button, and the results show delta H max in the area I have circled is larger than the distance from the seasonal high water table to the bottom surface of your BMP, you won't be able to tell just by looking at the graph. In this case, the seasonal high water table is 8 feet below the bottom surface of a BMP that is 90 feet in length. The height of the mounding is calculated to be 9.51 feet. The plot by itself looks normal, but is it? We have to understand what is being plotted and check it against the reality of our design. The depth to the seasonal high water table is 8 feet. This does not mean that the groundwater will rise up in real life above the surface of the basin bottom like this. It means the temporary elevation in the groundwater table, located at the center line and above the seasonal high water table, will intersect and exceed the elevation of the surface of the sand layer, that is, the bottom surface of the BMP, meaning it interferes with the infiltration capability of the BMP, and therefore it will take the BMP longer to drain. Adjustment of the basin design is therefore needed to reduce the impact of groundwater mounding. So we have to adjust our parameters and run the spreadsheet calculation again. To do that, we would have to reduce the value for R. We don't know exactly how much it would slow, but my first attempt would try reducing it by 50%. However, we are not ready to click Recalculate. The horizontal hydraulic conductivity is not adjusted since it is not affected by the reduced hydraulic gradient in the vertical direction. But the duration of infiltration period must be proportionally adjusted to reflect this slowing down. For example, we would double the initial value for T if we halved R. Although we don't know the exact rate to which the rate would slow, even if it is slowed by 1/2, we're going to check the mounding for a value of T that is within the maximum allowable time period. Sometimes we call this stretching the infiltration period. Next, we recalculate and check the result to see if delta H max is now less than the distance between the seasonal high water table and the bottom surface of the BMP. You might try this one more time with T a bit longer, as long as the R value is proportionally reduced. If that doesn't work, you're going to check Chapter 13 for an example of changing the dimensions of the infiltration area. With that explained, let's move on to our second example. We're going to look at a dry well for the example of an adverse impact. Even a small BMP can cause one. A site is located outside the coastal plain. A 7-foot high by 5-foot diameter dry well is proposed to store and infiltrate 137.4 cubic feet of roof runoff from a single-family home for the water quality design storm. The house has a basement floor located just above the groundwater table. The edge of the dry well is 10 feet away from the house. Soil testing was performed in accordance with Chapter 12. The soil testing report shows that the seasonal high water table is 2 feet below the bottom of the dry well. The tested soil permeability rate of the most restrictive soil horizon below the basin is 4 inches per hour. And the dry well is circular, so we calculate its area to be 19.6 square feet and input it into the equation to calculate the duration of infiltration to be 42 hours, which we see at the bottom of the slide there. Using the same type of chart, here are the values for our input parameters. 1/2 of the slowest tested saturated soil hydraulic conductivity rate is used for the recharge rate in the spreadsheet. The specific yield is the default value, 0.15. The horizontal hydraulic conductivity is the same as the recharge rate, since the site is located outside the coastal plain. The duration of infiltration period is 42 hours. And the initial thickness of the saturated zone uses the default value of 10 feet. The results show the maximum height of groundwater mounding, 1.11 feet, that will occur at the end of the duration of infiltration period at the center of the dry well. The temporary groundwater mounding does not encroach upon the bottom surface of the dry well, where it would have impaired infiltration had the mounding extended that high. Are we done? No. The rules require we also check the impact to the adjacent structure. Recall that the vertical axis is situated at the center line of the dry well, and the groundwater mounding curve is symmetrical on both sides of the vertical axis. The basement is 10 feet away from the edge of the dry well, which is 12.5 feet to the left of the center of the dry well. The spreadsheet results indicate the water table is also temporarily raised approximately 0.4 feet at the basement wall location nearest the dry well, which is an adverse impact prohibited by the rules. Therefore, the dry well may need to be moved farther from the building to avoid the adverse impact caused by the proposed infiltration. Per the USGS paper, an increase of 0.25 feet or less is an acceptable depth for underground structures to be temporarily affected by groundwater mounding. The mounding height at 20 feet from the dry well is just less than that. But considering the limitations of the Hanto spreadsheet I brought up earlier, it would be advised to place the dry well even farther than 20 feet from the basement, since the mounding decay, which is not modeled, may result in a rising of the groundwater level at the basement area higher than what is shown in the Hanto spreadsheet. This example shows that even a small infiltration BMP may have an adverse impact on nearby underground structures. If you haven't read it, Chapter 13 includes a lot more examples. Please see Example 7 in the chapter for guidance when replacing soil below an infiltration BMP. Also see Example 8 for the situation where exfiltration is used in the routing calculations and a mounding analysis is done for the volume exfiltrated for the 100-year storm. Additionally, Chapter 5 includes examples with groundwater mounding analyses and also includes examples about exfiltration in the routings, which is allowed in certain circumstances for the green infrastructure BMPs. So I would like to thank everyone for your attention. Here is my contact information. And if you have any questions, please feel free to type them into the chat. Meanwhile, we are going to be continuing to our next presentation. So this is going to be on some additional NJ-PACT rule amendments and updates, and this will also be presented by me. And just please stand by for a moment as I switch to the next presentation. So it'll just be another moment here while I get this ready. Computer's just being a little slow today, no problem. All right, here we go. For some reason it was not listening, and now we have it ready. So just got to share this. All right. everyone. I want to thank everyone for their patience as I get this ready. Just some slight technical difficulties, but we have it all set now. Okay. In this presentation, we will go over some of the amendments to the stormwater management rules, which were adopted on January 20th, 2026. We have addressed most of the amendments in prior presentations. Here we will cover some that have not been addressed or were only briefly touched on. Taking a look at what we will be focusing on, we will start with amendments to the applicability to major development section of the rules, NJAC 7:8 1.6. Then we will get into amendments to NJAC 7:8 5.2, specifically regarding new requirements on flow control devices. Then we will get into multiple amendments based on 3 separate topics: public transportation projects, climate change resilience strategies, and the new departmental variants. So let's get into the changes to NJAC 7:8 1.6, applicability of the rules to major development. The department will apply the stormwater management measures, the stormwater management requirements in effect on July 17th, 2023, when reviewing the following permits, including a stormwater management component, if the major development project submits an administratively and technically complete application or complete for public hearing under the CAFRA individual permit prior to July 20th, 2026. Flood Hazard Area Control Act, Freshwater Wetlands Protection Act, Coastal Area Facility Review Act, Waterfront and Harbor Facilities Act, and Highlands Water Protection and Planning Act. Also note the applicability section in the rules has no effect on the applicability of local ordinances or the residential site improvement standards at NJAC 5:21, which are governed by the requirements of the municipal land use law at NJSA 40:55D 10.5. Next, we will discuss one specific amendment to NJAC 7:8 5.2, stormwater management measures for major development. At NJAC 7:8 5.2 I5, in the previous rules, an orifice at the outlet of a BMP was required to be a minimum of 2.5 inches in diameter. In the new rules, this requirement has been removed. There is no longer a minimum size for an outlet orifice. However, in place of the old requirement, the rules require that any flow control device be designed to prevent the clogging of the flow control device while achieving the design and performance standards. This change may assist with meeting the new volumetric reduction standards, which we went over in the Stormwater Overview in Module 1, as well as the How to Review a Project presentation in Module 3. Next, we are going to discuss some other rule changes which are grouped together by topic. This one focuses on public transportation entities. Here are 2 new definitions found at NJAC 7:8 1.2 for new public roadway or railroad and public roadway or railroad project limits. The term new public roadway or railroad is used a couple times in the rules to emphasize that a new public roadway or railroad is not eligible for the waiver at NJAC 7:8 5.2e. And the term public roadway or railroad project limits is used extensively in the amended NJAC 7:8 5.3, the Green Infrastructure Standards, which we will get into in a few slides. Public transportation entity has a slight update to its definition. Interstate agencies are now included. Independent state authority is a new term defined in NJAC 7:8 1.2. A reason for its addition is that it's included in the public transportation entity definition, but previously was not defined. Here is the rule text for NJAC 7:8 1.6 E and F under the applicability to major development section. So please take a look. I'll leave up this slide for 10 seconds or so for everyone to read. And then we reframe the wording of the previous slide here to provide the key points. When a public transportation entity submits a major development application subject to department review for a public roadway or railroad project, and a preferred alternative or equivalent milestone is reached, the version of the rules that apply depend on when the preferred alternative or equivalent milestone is reached. If the preferred alternative or equivalent milestone was reached prior to March 2nd, 2021, the project is subject to the rules in effect on March 1st, 2021. If the preferred alternative or equivalent milestone was reached on or after March 2nd, 2021, the project is subject to the rules in effect on the date the preferred alternative or equivalent milestone is reached. However, in this situation, if a public transportation entity initiates a substantial change to a project that reached a preferred alternative or equivalent milestone, the project will be subject to the rules in effect when the amended milestone is reached. The amended NJAC 7:8 5.2e clarifies that the waiver is not eligible for the construction of a new public roadway or railroad. The waiver is for the enlargement of an existing public roadway or railroad, or the construction or enlargement of a public pedestrian access. There are extensive updates to NJAC 7:8 5.3 F through K. Rather than show them all here, we are just offering some key points. For a public roadway or railroad, a public transportation project can use GIBMPs from tables 5-1 and 5-2 to meet the quantity, quality, and groundwater recharge standards. And then after a demonstration through a comprehensive hierarchical approach to ensure the implementation of GIBMPs to the maximum extent, if the unsuitable hydrologic, hydraulic, or physical conditions prevent implementation of GIBMPs, non-GIBMPs from Table 5-3 may be used for new and reconstructed public roadway or railroad. And then lastly, for enlargement of an existing public roadway or railroad, a waiver from strict compliance from the GI requirements may be requested if the comprehensive hierarchical approach demonstrates that the quantity, quality, and/or groundwater recharge standards cannot be achieved. New public roadways or railroads cannot apply for this waiver. In the quality standards at NJC 7:8 5.5 B2I, there is a provision for public transportation entities. Where a public transportation entity demonstrates that achieving 80% TSS removal pursuant to B2 above for a public roadway project would require acquisition of developed or otherwise encumbered land outside of the entity's existing right-of-way along the section of roadway being improved or constructed, the public transportation entity shall instead provide water quality treatment to the maximum extent practicable, with a minimum water quality treatment of 50% TSS removal for all new and reconstructed motor vehicle surface. To round out this public transportation entity part of the presentation, we take a look at NJC 7:8 5.6 D3, where there is a provision for public transportation entities in meeting the volumetric reduction standard. The volumetric reduction standard of this subsection shall not be applicable to projects that are undertaken by a public transportation entity in cases where the project meets the definition of major development solely because the project results in increased capacity of an existing stormwater conveyance system. Next, there are a couple of amendments to the rules referring to a climate change resilience strategy. Under the Regional Stormwater Management Planning subchapter of the rules, there is the new NJAC 7:8 3.4A7 for a climate change resilience strategy. Similarly, under the Municipal Stormwater Management Planning subchapter of the rules, there is the new NJAC 7:8 4.2C15 for a climate change resilience strategy. The NJPACT rules require a climate change resilience strategy as part of the Municipal Stormwater Management Plan. Now we will talk about the entirely new subsection of the rules at NJAC 7:8 5.10 for the departmental variance from the design and performance standards for stormwater management measures. We provide the full text here in these next few slides, which we encourage you to read through. I'll leave up this slide for 15 seconds or so to give everyone a chance to read through. Continuing through the rule text for NJAC 7:8 5.10, again, I'll leave up this slide as well to give everyone a chance to read. And here is NJAC 7:8 5.10b. I will continue on to some key takeaways for this subsection of the rules. To grant the departmental variance, the department needs a written report prepared by the MS4 permittee that demonstrates the justification for granting the variance and that the requirements for granting the variance and conducting off-site mitigation are met. If a public roadway and railroad project by a public transportation entity is granted a variance from the GI standards, the public transportation entity may use small-scale GI BMPs from Table 5-1 or non-small scale GI-BMPs from Table 5-2 in the mitigation project to meet the GI requirements. And this is just a small change separate from the departmental variance section of the rules, which we wanted to highlight. I'm sure you've heard about this email address before. We've emphasized it multiple times throughout the training, but this is a new email address, stormwater management rules at dep.nj.gov, which shall be used for questions or submissions regarding the chapter. And this email may also be used for other questions for the Municipal Stormwater Engineering Unit, for example, for questions related to this training, as we've been discussing. Here is our contact information and a link to the main Stormwater webpage. Please feel free to email us with any questions or comments. And now I'm going to check in with our moderator, Chang-Yi, to see if there's anything we need to address before we move to the next presentation.
I think we addressed those questions. So we may continue the presentation. Thank you.
All right, thanks, Chang-Yi. So next up is going to be Lisa Schaefer with the Green Infrastructure Example 1. Please stand by while I hand control to Lisa.
Okay, thank you, everyone. Well, in earlier modules, we introduced what we mean by green infrastructure, and we also covered some of the regulatory requirements pertaining to it. So today, I'll start with an example that incorporated GI into the design per their report, and then I'll evaluate it to see whether it follows what's spelled out in the GI fact sheet, which I covered in an earlier module. So the goals today will be to review the site plans and the stormwater management report to determine the applicable standards and identify any errors within the design. So that means I'm going to see if and where the design falls short, if that's the case. But I won't have time today to discuss potential solutions. So all reviews require figuring out which standards apply and then checking them for compliance. So the questions we must ask and answer when we're doing a review is, what is the disturbance on this site? Does it trigger major development? Will the project be required to do water quantity, groundwater recharge, water quality, and groundwater mounting? So we're going to figure out all of that to see if those standards will apply to this review and how they'll be addressed using green infrastructure as required by the rules. So, of course, it's important to know what the site looks like, what the pre-construction conditions are, and what the existing land cover is. Plus, we need the soil testing information. So let's dive into our example. All right, the property in question is a farm that had been in existence for many decades. It covers over 18 acres. The frontage road running east to west is a county route with sizable traffic volumes. The property is adjacent to some forested properties along the rear lot line, which is also a stream corridor for a freshwater non-trout tributary. The property drains toward the stream, and then that flows to the south before crossing under the roadway east of the property via a culvert. So this is the topographic view with the stream, the wetlands delineation, and the 150-foot wetlands and 150-foot riparian buffers shown as various dashed lines. The green arrows denote the general direction in which runoff flows over the land surface. All right, the proposed development includes the clearing and grading of the property, construction of 25 single-family homes, widening of the existing road found on the right side of the plan, and another internal road. Okay, both each terminate in a cul-de-sac with a 50-foot radius. The stormwater management report indicated that 4.7 acres of impervious cover is proposed, but it didn't break that down into motor vehicle surface versus rooftop. So I started checking the coverages, and the homes are about 0.35 acres each on average. So that's 8.75 acres. Maybe it was more than, all right. Anyway, the proposed roadways are 28 feet in width, and by my estimate, roughly 70,000 or square feet or 1.6 acres of new motor vehicle surface are proposed. Additionally, the existing portion of the roadway along the east side of the property will be newly collected where no collection system existed before, so it also counts as regulated impervious surface. So clearly, the total definitely exceeds thresholds for major development. So for this project then, compliance must be demonstrated with the GI requirement and water quality, stormwater runoff quantity control, groundwater recharge, and if infiltration is proposed, groundwater mounding, plus the safety requirements, and of course, let's not forget maintenance. So to address water quality and the green infrastructure requirement, 4 small-scale bioretention basins with underdrains are proposed, and here's where they would be located. So first, let's look at the soil exploration map, which indicates quite a number of test pits were completed. Although at the time that the plan was prepared, only one central stormwater management basin was included, as shown in the light blue area in the center of the site. So maybe the preliminary concept predated any of the rule amendments from 2023. So as you know, major development projects are required to use green infrastructure best management practices, and they're smaller in scale, and they treat runoff close to the source. So it's good that the designers realized the single basin approach wasn't compliant and went with multiple BMPs. So the reviewer would also want to check that for the revised design, the proper number of test pits and soil borings were performed. In this case, the soil testing report was not revised to meet the testing location requirements for the updated basin layout. Anyway, from the test pit findings, the seasonal high water table was determined to be at depths between 3 and 6 feet, mainly because modeling was observed, and the teal color boxes show these depths that were, the depths below existing grade. Where the depth is preceded by an asterisk, cemented soils were observed. All right, so additionally, from test pits 10, 11, and 12, the tested permeability rates were far below the minimum field rate of 1 inch per hour, meaning GI BMPs designed to infiltrate could not be used. And lastly, here are the approximate locations of the 4 proposed BMPs so that you can see which test pit most closely corresponds to the proposed basin. They seem to be within 25 feet of the infiltration area of the new basins, which is also something that you would check when basins are relocated. So let's look at the drainage area map for the proposed condition next. All right, this map is a little hard to read, and I apologize. But fortunately, the contributory drainage area to each underdrained small-scale bioretention basin is less than the maximum allowable of 2.5 acres, as specified in the rules under subsection 5.3 in item B. So that requirement is met for green infrastructure BMPs. However, the placement of the BMPs is too far from the source of runoff. Plus, the GI BMPs should be distributed throughout the site and not grouped together the way that they are. All right, so, and why is that? Well, the motor vehicle surfaces are generating runoff, and that requires treatment, and that means the GI BMPs need to be near them. Also, if the rooftop generated runoff or runoff from other impervious cover that's not motor vehicle surface is commingling with runoff from the roadways, then the commingled volume must be treated. So no information was provided regarding the roof drainage. All right, let's move on and look at each basin individually. All right, basin 1 is on the left side of the image, and it's shaded in pink next to the cul-de-sac on the west of the development. Runoff is collected in lawn area inlets, and it's piped to the basin. All right, plus the cul-de-sac is graded so that the runoff flows to the east more than 50 feet along the curb to the inlet on the piping run, even though this basin in the pink area is so close to that huge area of pavement. So moving on to basin 2, it's shown here in blue at the center. So it's not close to the source of the runoff draining to it. All right, and that's this blue area over here. Okay. All right. So since the contributory drainage area is far away, the location of basin number 2 doesn't meet the rule requirement for GI. And basin 3, it's the area to the right that also happens to be shaded in pink. This basin is too far from the motor vehicle surface, like the entrance road on the east end of the site and the internal roadway in the pink shaded area on the right. All right, the yellow area is for basin number 4. And look how far runoff has to travel before it gets over there. Okay, so even though the drainage areas are below the contributory maximum limit, none of the BMPs reported as being GI BMPs are close to the source of runoff, nor are they really distributed throughout the site. So the layout itself doesn't meet the GI requirements. Lastly, the lighter green area in the center has roof area generated runoff that's not detained. So that will be an issue when we address how the site complies with the quantity control design and performance standards. All right, so we know that the design does not meet the requirement to use GI, so that's strike 1. All right, and we're going to look at other instances in which the project does not comply with the rules. So here's a basin detail. All right, the details for each of the BMPs otherwise show most of the requirements for online bioretention systems with underdrains, with weirs and orifices to attenuate discharge from the larger storm. So far, so good. However, I didn't see the bioretention media specification, so that would be something I would add to my review letter. I also didn't see the maintenance plan. So without these 2 items, the BMPs do not merit their TSS removal rating, meaning they do not meet the water quality standard. So that would also go into the review letter, all right, as strike 2. Now, there's another interesting observation from the review of the report, namely that the stormwater calculations, they were prepared in 2022. They used the type 3 storm distribution for the 2, 10, and 100-year design storms. But per the 2021 publication of Chapter 5, NOAA C and NOAA D distributions were to be used. So that would also go in the review letter, and I'd like to see new calculations for that. So far, it's not looking good for meeting the runoff quantity control. And for now, I'm just going to mark it as non-compliant. All right, so the groundwater recharge review, well, it's interesting to say the least, and it needs a slide of its own. All right, so the proposed project was shown to not meet the top 3 standards on the previous slide, right? That's why they're grayed out. But for groundwater recharge, the report stated the project demonstrates compliance with subsection 5.4 of the rules because all the runoff is infiltrated. No, that's another error. Why? Well, because they're only proposing under-drain BMPs. I don't know, but perhaps the designer thought the movement of water through the planting media was good enough to meet the requirement. Under-drain systems are not infiltration BMPs, and they cannot be used to meet the groundwater recharge requirement. So furthermore, this is where it got really strange. The narrative of the stormwater report erroneously stated that these under-drain basins are sufficient to address the groundwater recharge, claiming that the proposed 2-year hydrograph volume was less than the existing 2-year volume as shown in the excerpt that I've got here in the red box. But the narrative was never revised. as the report calculations themselves show an increase in the volume of runoff generated by the proposed design. So once more, the proposed design doesn't demonstrate compliance. All right, so we'll let them know that the project will have to be revised along with the narrative. So another thing that I would probably add to the review letter that is the reminder that if the, well, maybe not, but if the design were actually infiltrating runoff into the underlying soils, then I'd have to see a groundwater mounding analysis is included with the report. That means that if the pervious pavement, rain gardens, small planting areas, or dry wells are incorporated, say, into a revised design, then their impacts on the nearby structures would be required in addition to the assessment of the impacts of infiltrating stormwater into the BMPs, like Peter showed you in the prior groundwater mounding presentation. So it looks like the project failed to meet all of the design and performance standards that I covered today. So I'm just about done. Let's sum things up. All right. It's important to answer the 3 questions when you review a design to make sure that GI is properly implemented on site. So that means the GI BMPs are located close to the source of runoff, they're dispersed throughout the site, and that the drainage area limitations are met. So this example did not answer 2 of the 3 questions from the fact sheet with a yes. So even though they claimed it was GI, it is not worthy of the GI per our guidance. Okay, so that means the requirement to use GI properly has not been met. So this would also be reflected in a review letter, and I would request revisions to get the project in compliance with the rule requirements to use GI. All right, let's let this person in. All right, on the previous slide, I showed the project did not comply with the design and performance standards for water quality, quantity control, and groundwater recharge. So like I said, we need a redesign. All right. So if you're unsure about something, you can reach out to ask us questions. You have our email address. You can also email me directly. And I want to thank you very much for your attention. Mr. Moderator, are there any remaining questions to be answered?
I think it's already 2:30 approximately, so we are going to take the 10 minutes break. So please come back at 2:40. Thanks.
Okay, thanks everyone.
All right, welcome back, everyone. We will now continue on with plan review example number 2. So the goals of this presentation are the same as those for the prior example. We will focus on whether the project meets the requirements for green infrastructure, and we'll look at what was proposed and identify where this design falls short. So let's take a look at what's going on in our example here. We'll start with what the site looks like, what the pre-construction conditions are, and what the existing land cover is. So this property in question is a site covering roughly 11.7 acres that is primarily undeveloped and wooded. It contains the abandoned ruins of a single-family residence and related outbuildings on the northwest portion of the site. The site does run alongside a state highway, as you see in the image. And to the west of the property is a conservation easement containing a ponded area draining to a tributary of a local river. The site it itself receives stormwater runoff draining from the east side of the divided highway, and there are some mapped wetland areas on the site as well. So let's take a look at the drainage area map for the existing conditions. So here's a topographic view. As you can see, the arrows here depict how the site would flow. Some flow from the road to the northwest and some flow from the highway to the east. Everything is going to be flowing towards the southwest portion of the site, with the high point for the site being in the northern area. The proposed development includes the clearing and grading of the property. There will be a construction of 152 age-restricted affordable housing units in a single multi-story building. There'll also be a single access driveway, surface level parking, and multiple stormwater basins that will discharge to the southwest corner of the property to support the existing drainage patterns. The project will be constructed in 2 phases. The first will include 84 units and the second 68, which are located on the left side of the building as shown. From the stormwater management report, the narrative states there are 3 small-scale infiltration basins along the southern border that are designed to provide extended detention of the larger design storms, plus a northeast detention basin for the off-site runoff entering the site to the north and east. So immediately there's a big issue with this design. All 3 of these basins that are proposed to meet the GI requirement, they're grouped at the southern side of the project. Remember, clustering these BMPs together is not compliant with the GI requirements. The BMPs have to be distributed throughout the site and manage stormwater close to its source. The proposed design is going to rely upon infiltration of runoff to meet the groundwater recharge requirement and water quality. So let's look at the web soil survey results, followed by the soil testing data before we evaluate the overall design any further. As you see here, from the soil survey, the site is mapped as HSGA, which is pretty promising for infiltration. So let's look at the soil testing findings. 2 sets of soil investigations were conducted here. A total of 20 test pits were performed. The first group, shown in green, are from April 2021, and the second group, shown in blue, are from January 2022. I've superimposed the 3 proposed small-scale infiltration basins onto the soil testing map just to show which test pits correspond to the respective basins. Your review would also include a check of whether a sufficient number of test pits and soil borings were performed, along with the depth of investigation, but we're not going to cover that here, just to focus more on the GI aspect. I've also added the depth at which the logs show the soil permeability was determined, taking note that groundwater was not encountered at any of these locations. The brown shaded rectangles denote results for other test pits. And for test pit 3 and 5, groundwater was encountered at 5.5 feet below existing grade. For test pit 6, groundwater was found at 6 feet below grade. And lastly, a perched water table was found for test pit 8 at 10 feet below grade. As with the blue shaded test pits, groundwater was not encountered at the ones I did not call out. So the report shows quite a variation in the test results for permeability. So let's look at a table of the testing results. So here's that table, and I've circled the locations where the field tested permeabilities were less than an inch per hour. Unless soil replacement is proposed, these spots are not suitable for infiltration BMPs. Given the low permeabilities at the encircled test pits, we will have a problem with the ability of the orange and yellow shaded basins to drain properly. And we'll add this to the review letter. So next, let's look at information found in the stormwater report, which states the 3 basins are designed as small-scale infiltration basins, but we do have to check if they really are. So this is the node diagram from the stormwater management report. These are usually upfront in the materials that are submitted, and I use them to look at how the site is modeled and make notes as I start my review of the project. Basins 27P, 24P, and 38P are the basins numbered 1 through 3 respectively. We have superimposed the inflow areas taken from the basin summary reports, with the totals appearing in the brown shaded boxes. At first glance, the node report shows an interconnection, meaning we will need to look at the basin details to see if in fact they function independently for the water quality and groundwater recharge design storms that's required in the GI fact sheet. In this case, Basin 1 drains to Basin 2, which drains to Basin 3. The connections between BMPs here, and perhaps the drainage area map can provide clarification, and after that, we'll look at the construction details to see how the design functions. So here is the drainage area map for the post-construction condition. This shows the contributory drainage to each small-scale bioretention basin is less than the allowed maximum of 2.5 acres, which appears to demonstrate compliance with NJAC 7:8-5.3b. But we do have to dig further as the reviewer to not complete, because we have to check the details on how these basins perform when it comes to the water quality, the 2-year, 10-year, and 100-year design storms, meaning how interconnected are they? So let's check some details here. So before we dive into the construction details, I just want to say that I'm not including further review information for quantity control and groundwater recharge. For the required groundwater mounting analysis for infiltration BMPs, The only analysis was for Basin 1, and the most restrictive hydraulic conductivity with the factor of safety was not used in the calculations. So this should also be in the review letter. So here's a close-up image taken from the plans, and I've added construction details that shed light on how these basins function. So Basin 1 is on the right, and A-9 is the outlet control structure for it. The top grate is the sole means by which runoff discharges from the basin. Since the grate is at elevation 63, the water quality design storm infiltrates, and the 2, 10, and 100-year storms overtop the grate and flow to Basin 2, which has outlet structure B-11. If you look at the detail, the lowest orifice has an invert of 50, which is below the water surface elevation of the water quality design storm that's contributory to Basin 2. We also see in the plan view that there is an additional inflow via a flared end section, B-10, and this inflow is not being treated because this is flowing out the outlet control structure. So Basin 2 wouldn't meet the design criteria for infiltration basins according to the BMP manual. Similarly, the lowest orifice at OSC-10 is below the water surface elevation of the water quality design storm. An additional inflow enters via the section called C-9, which is not treated by the basin. So in conclusion, Basins 2 and 3 do not meet the design criteria for infiltration basins according to the BMP manual and would not merit the 80% TSS removal rating. These contributory drainage areas would most likely be larger than the ones that you would find in Table 5-1, and they would then be more suited for those in Tables 5-2. Which will require a variance before they can be used for quality and recharge. Waivers are for the enlargement of an existing public roadway or railroad, or the construction or expansion of a public pedestrian access, which this project is not. So the next slide, we will visit the subjects of variance. So there are strict standards to be met in order to grant a variance, as you've heard. More specifically, the municipality has to have a mitigation plan in place that identifies what measures are necessary, potential mitigation projects, and or criteria to evaluate mitigation projects that can be used to offset the deficit created by granting a variance. Additionally, the conditions shown here, in part from the rules, must be met. The applicant has to demonstrate it is technically impracticable to meet one or more design and performance standards on site. And those reasons can only be engineering, environmental, or safety based. And furthermore, the variance cannot be for the entire site unless an analysis is provided for each drainage area within a site. And the applicant also has to demonstrate maximum possible compliance is provided by the design. So don't forget, there's also a reporting requirement for variances. What's not shown in this excerpt is item 3, which is about the mitigation plan, which has to be within the same HUC 14 and approved no later than the preliminary or final site plan of the project. Moreover, if the variance is for green infrastructure, then the mitigation plan must use green infrastructure BMPs to manage an equivalent or greater area of motor vehicle surface. There are 7 other parts to the mitigation plan from this section of the rules that I have not covered here, but in short, a municipality cannot grant a variance now like it may have done in the past. Since information was also not provided on mitigation projects, this project is not compliant with the rules. So let's conclude the review of this example by answering the 3 green infrastructure questions for the proposed design, even though only one small-scale infiltration basin was actually proposed. They must all be answered with a yes for the project to meet the GI rule requirement. So the first one is the stormwater managed close to its source? Well, the BMPs were not located next to the parking areas. So the answer to the first question is no. The second question, are the BMPs distributed throughout the site? Well, the BMPs were all located near each other along the southern property line. So the answer here is also no. And the third question, are the drainage area limitations met? It doesn't look like Basin 2 and 3 infiltrated the water quality design storm, and were instead discharging downstream during the water quality design storm. So the answer likely for question 3 is no. So to wrap things up, this project does not comply with the requirements to use green infrastructure to meet the design and performance standards for water quality, groundwater recharge, and stormwater runoff quantity control. So that about does it for this plan review example 2. Thanks for your attention. If there's nothing else that needs to be addressed here by our moderator, we can move on to our next presentation.
Yeah, please move on to the quiz. Thank you.
All right, so up next, we will administer quiz number 4, and Peter Pliantos will help with that. Peter?
Okay, thank you, Manesh. Just getting the quiz presentation ready. All right, it is now time for the 4th and final quiz for the course. And one thing to note about the quiz is that while there are questions from today's module, we also have the 2 hardest questions from modules 1, 2, and 3 included in the quiz. So let's get started. As an important reminder, upon the conclusion of the course, we will send you a course evaluation survey within 2 weeks. You then need to complete and send back that course survey within 1 week. The survey must be completed to receive either a certificate of course completion or a certificate issuing CPC credits. So if you review for an MS4 permittee, attended all 4 modules, completed all 4 quizzes, and are required by permit to complete this training every 5 years, you'll have to complete the survey. Likewise, if you are a professionally licensed engineer and you wish to receive CPC credits, you'll have to complete the survey. So we emphasize here for you to please complete the evaluation survey. And lastly, as we've been saying, slides and recordings of this training will be available on the training website at the URL shown on the bottom of the screen. And they will be updated for future sessions of this course, which we typically try to host twice a year. As with the other quizzes, there are multiple ways to access the quiz. The link at the top of the slide will take you to our training website, which has the link for quiz 4. The link at the bottom of the slide will take you directly to the quiz, and the QR code, which can be used with your phone, will also take you directly to the quiz. And the link at the bottom and the QR code will also be posted into the chat. You must answer every question before you can advance to the next screen, and you must click Done at the end of the quiz to get credit. And please note, you may only take the quiz once. So the time is now 2:59, and we're going to give 20 minutes to complete the quiz. So we will meet back at 3:20 to do the quiz review. So please work on the quiz. And if you finish the quiz before then, you can take a short break, and we're going to begin the review at 3:20. The URL and QR code will stay on the screen for the entire duration of the quiz if you need it. So good luck, everyone. Let us know if you have any issues. And again, we'll meet back here at 3:20 for the review. All right, welcome back, everyone. It's now 3:20. Looks like almost everyone has completed the quiz. If you're still finishing up the quiz, that's okay, but please be sure to finish it soon. Meanwhile, we will begin the quiz 4 review. Question 4, true or false? When the groundwater mounding reaches the bottom surface of a BMP designed to infiltrate, the infiltration into the subsoil will be adversely impacted. This statement is true. When the mounding reaches the bottom surface of an infiltration BMP, the hydraulic gradient is going to be reduced significantly, and the flow rate infiltrated through the BMP is going to be reduced as well. Question 5. What method is used to calculate the groundwater mounding height? The correct answer is B, the hand-touch spreadsheet. This spreadsheet, which you can find on our website with Chapter 13, will calculate the maximum height of the groundwater mounding directly below the basin. Question 6. Which of the following is not an activity qualifying for temporary disturbance under NJAC 7:8 5.2d? The correct answer for this one is C, construction of a 20-foot wide public pedestrian access with closed graded asphalt. In order to meet the temporary disturbance exemption under NJAC 7:8 5.2d, the public pedestrian access must have a width not exceeding 14 feet, and it must be made of permeable material. Number 7, true or false? Green infrastructure, or GI, is defined in NJAC 7:8 as a stormwater management measure that manages stormwater close to its source by 1, treating stormwater runoff through infiltration into the subsoil, 2, treating stormwater runoff through filtration by vegetation or soil, or 3, storing stormwater runoff for reuse. And this is true. The definition quoted here matches up with what is found in the rules. Question 8. Which questions need to be answered yes when designing a major development to meet the GI requirements? And the correct answer is all of the above. So, as found in the GI fact sheet, the stormwater must be managed close to its source, the BMPs must be distributed throughout the site, and the drainage area limitations, as applicable, must be met when designing a major development to meet the GI standards. Question 9. Which of the following GI BMPs has a contributory drainage area limit that is other than 2.5 acres? Dry wells is the correct answer. Dry wells have a 1 acre contributory drainage area limit per NJAC 7:8 5.3b. Number 10. Yes or no? Can GI BMPs be located near one another for the following scenario? There are 7 dry wells located adjacently on 3 sides of a large building. No more than 1 acre of roof runoff is directed to each individual dry well, and each dry well will function individually for the water quality and recharge storms. And the correct answer here is yes. So we want to check the answers to the 3 questions for GI that we've emphasized a few times today. So first, the dry wells are located near the source of runoff. They are also distributed along the 3 sides of the building, and each dry well does not exceed its individual contributory drainage area limit. Each functions individually for the water quality and recharge storms. So in that case, answering those 3 questions that way, the answer is yes. Number 11. Which of the following is recognized as a co-benefit of using green infrastructure? And the correct answer is D, all of the above. As described on pages 1 and 2 of the Green Infrastructure Fact Sheet, all 3 of these are environmental, social, and economic co-benefits of using green infrastructure. Additional co-benefits include increased property values and the removal of pollutants through the air through greater utilization of vegetation. Number 12. Yes or no? Is the interconnection between GIBMPs in the following scenario acceptable? A small-scale bioretention system infiltrates runoff for the water quality and groundwater recharge storm events, meeting the 2.5-acre contributory drainage area limitation. The 2, 10, and 100-year storm events are discharged from the small-scale bioretention system to a large-scale infiltration basin, which is used only for water quantity. The answer to this is yes. From NJAC 7:8 5.2, the downstream large-scale infiltration basin can only be used to meet the quantity control requirement and is not subject to the contributory drainage area limitations found in 7:8 5.3b. Additionally, the upstream small-scale bioretention system fully infiltrates the water quality design storm and the recharge storm. Number 13, true or false? BMPs from Table 5-2 can be used to meet the stormwater quality requirements without obtaining a waiver or variance from NJAC 7:8 5.3. And this statement is false. BMPs from Table 5-2 can be used for stormwater runoff quantity only. For them to be used for stormwater runoff quality, a waiver or variance from NJAC 7:8 5.3 must be obtained. Question 14. Which of these can be used to demonstrate compliance with the water quantity design and performance standard? The correct answer is B. Design stormwater management measures so that the post-construction peak runoff rates for the current and projected 2, 10, and 100-year storm events are 50, 75, and 80% respectively of the pre-construction peak runoff rates. Number 15. At a minimum, how often is the responsible party required to evaluate the effectiveness of the maintenance plan? C is the correct answer, 1 year. The stormwater management rules state that the responsible party must evaluate the effectiveness of the maintenance plan at least once per year and adjust the plan as needed. Number 16. Soil testing logs prepared in accordance with Chapter 12 are required for which of the following BMPs? Correct answer is all of the above. So they all have a minimum separation from the seasonal high water table, which you can find in their respective BMP manual chapter. Soil testing would therefore be required for all of these to ensure that they meet the required separation. Number 17, yes or no? Can the Delmarva dimensionless unit hydrograph be used for the redevelopment of a 2-acre entirely impervious site located within the coastal plain? The correct answer is no. The Delmarva dimensionless unit hydrograph must be used when modeling watersheds within the coastal plain region of New Jersey, with just a few exceptions. It cannot be used to size a manufactured treatment device, or MTD, as it may underestimate the peak flow rate entering the MTD. Also, for an entirely paved site, the significant surface storage associated with the coastal plain is no longer present, also resulting in underestimated peak flow rates if the Delmarva is used. Additionally, the Delmarva should only be used in areas that have an average watershed slope less than 5%. If any of these situations are proven to be present, the SCS standard dimensionless unit hydrograph must be used. And a side note on this subject, if the Delmarva is used in the pre-construction condition, it must also be used in the post-construction condition. Same idea goes for the SCS. Question 18, true or false? When using the NRCS methodology for calculation of stormwater runoff, the Type 3 rainfall distribution must be used for developments in New Jersey. This is false. As discussed in the calculations presentation for Module 2, NOAA C or D distributions must be used, not the Type 3. Question 19. Which of the following would be exempt from the groundwater recharge standard? The correct answer is B, previously developed portions of a site in a designated center. So just being in Planning Area 1 is not an allowed exemption from the groundwater recharge standard, nor is redevelopment automatically exempt. Only previously developed portions of sites in the designated locations listed on this slide can be exempted. Question 20. If you have an impervious surface that has existed for 10 years, but have removed this impervious surface prior to the submission of the application that includes a stormwater management review component, can you still use this impervious surface as an existing condition in the stormwater management calculations? And the answer here is no. We use the land cover that has the lowest runoff potential that existed on site in the past 5 years for the existing condition. If you remove impervious cover, anything you replace it with is going to have a lower curve number, regardless of when that impervious cover was removed. So impervious surfaces removed prior to the application cannot be counted as an existing condition. Question 21. Can an infiltration basin be designed with a perforated underdrain pipe as a means of discharging runoff from the basin? And the answer is no. An infiltration BMP cannot have an underdrain pipe if it wants to meet the criteria for an infiltration basin in the BMP manual. All right, so that is the end of quiz 4. So thank you for your attention. If you have any questions, please add them to the chat or feel free to email the group or myself. Up next is Max Murphy and Lisa Schaefer, and they will be discussing the MS4 program and updates to the BMP manual and webpage, along with some training information. So please stand by while I hand control over to Max.
Good afternoon, everyone. My name is Max Murphy, and I'm an environmental specialist in the Municipal Stormwater Permitting Unit in the Bureau of NJPT's Stormwater Permitting. And today I will be giving you an overview of the MS4 program. As we go through the presentation, I will address key aspects of our Tier A public complex and highway agency MS4 permits. Afterwards, Lisa Schaefer will take over to provide you with the updates that have been made to the BMP manual and the webpage of the Stormwater Management Rule amendments. After, there will be some course-related information, including the accreditation and evaluation, so please stick around until you are dismissed so you are marked complete for this module. Finally, please leave any questions you have in the chat as we move through the presentation. MS4 permits include a wide range of requirements, including these key requirements noted here. We will be going into more detail regarding these requirements as we move through the presentation. Some of these requirements have been added in the most recent renewals of our permits. First, we will discuss our 5G3 permit for construction site stormwater runoff. This general permit, needed as an addition to MS4 permits, controls stormwater discharges to surface water from certain construction activities, including clearing, grading, and excavation. These generally are construction activities that disturb 1 acre or more of land, or disturb less than 1 acre, but are a part of a larger plan of development or sale. This permit is essential for anyone working with major development projects. As for post-construction stormwater management, first, it is important to note that design engineers cannot approve their own designs. The designer and the approver must be 2 separate engineers. Next, for any amendments to the stormwater management rules, training sessions will be necessary for stormwater design reviewers. This is because attendance at this particular training is only required every 5 years, and we do not want to wait that long to train people on the new amendments. Training will be announced by the department upon the implementation of a rule change, and attendance is mandatory and must be completed within 1 year of the adoption of the amendments. Community ordinances, or regulatory mechanisms for public complexes and highway agencies, are a key way to minimize stormwater pollution and flooding throughout communities, not just at major development sites. The purpose of these is to have mechanisms in place to keep pollutants out of stormwater so they do not make their way to streams, lakes, and other water bodies. The top 5 on the list are the regulatory mechanisms applicable to the public complexes, while the top 4 are the regulatory mechanisms applicable to highway agencies. Retrofitting of inlets is another important part of the MS4 program. All remaining storm drain inlets that have not yet been retrofitted must be retrofitted by December 1st, 2027 for Tier A's, December 1st, 2028 for public complexes, and December 1st, 2029 for highway agencies. When doing so, either the entire structure can be replaced with an updated one, or you may attach a bolt-on plate to reduce the size of the vertical opening of the old inlet as shown in the top image. This image will not be in the slides emailed to you, but we have added it retroactively to show the bulk rate option. And additionally, all newly installed inlets must have a catch basin or other BMP to collect solids. Tier A permittees are required to establish a program that ensures that all private stormwater facilities are properly inspected, cleaned, and operated if the facility was built after February 7, 1984. Operation and maintenance responsibilities may be assigned to commercial property owners, developers, and homeowners associations. However, individual homeowners cannot be assigned responsibilities for stormwater facilities that were designed to manage stormwater for the surrounding area. Private facility owners and operators are responsible for providing documentation to the permittee that the stormwater facilities on their property are inspected annually and maintained according to the approved maintenance plans. If there is not an approved maintenance plan, the permittees can prepare a retroactive maintenance plan for certain infrastructure or inspect at least 4 times annually and after each rainfall of 1 inch or more. Permittees need to keep an inventory of the locations and types of private stormwater facilities, as well as records of inspection, cleaning, maintenance, and repair work, and any problems or enforcement actions that have been taken. The location and type of these private facilities will need to be included in the map created for the Watershed Improvement Plan, which we'll cover some in a little bit. All Tier A and Highway Agency MS4 outfalls are to be inspected for stream scouring and illicit discharge at least once every 5 years. Permittees must inspect at least 20% of the total annually on a rotation so that all outfalls have been inspected by the end of the 5-year permit cycle. Public complex MS4's outfalls are required to be inspected every year. Check your specific MS4 permit for any additional requirements. The definition of outfalls includes not only outfall pipes, but open conveyances as well. All new or newly identified outfalls, as well as complaints or reports of scouring or illicit discharge, must be inspected within 30 days, and any reports of scouring need to be remediated within 12 months of discovery unless the department approves additional time. All permittees should have already submitted an MS4 infrastructure map electronically to the department by January 1st, 2026. We are looking for georeference shapefiles, geodatabases, or AutoCAD files with non-applicable data removed. A PDF map sent to us via email will not complete this requirement. If you have not yet submitted the mapping and need assistance, the department has a free mapping tool and can provide ArcGIS online licenses for free to any interested permittee. Additionally, if any permittees already have their own ArcGIS license and would like to access our shared editing map, we are able to invite you to help edit the map. So please reach out to your county case manager to get that set up. If the DEP mapping tool is used, data submittal will be automatic. If the department's tool is not used, files will need to be uploaded via NJDEP Online. The infrastructure map must be reviewed annually or more frequently as necessary and updated to include the location or attributes of any new or newly identified MS4 infrastructure. The map must also be posted on a dedicated stormwater webpage when it is complete. There are many water quality impairments and resulting TMDLs that affect waters across the state. These impairments affect fish and aquatic biota, drinking water intakes that supply the water we drink, and even rivers and coastal waters where many of us swim every summer. Many of these waters are affected by MS4 discharges, and therefore the department requires that permittees develop a watershed improvement plan to determine what improvements can be made to reduce their contribution of pollutants that are causing impairments to state waters. The watershed improvement plan consists of 3 phases. The first, which involves data collection and summarization, which was due January 1st, 2026 for Tier A's and public complexes, and will be due January 1st, 2027 for highway agencies. Guidance for the Watershed Improvement Plan can be found on the department's website. Finally, I wanted to speak a bit about the WRC permit. Wood waste recycling and leaf composting are federally regulated industrial activities that require an Egypti's stormwater permit. Through MS4 compliance audits, we found that MS4 facilities that perform these activities were not properly managing their stormwater discharges and therefore contributing pollutants to surface and groundwater. This general permit became effective January 1st, 2023, and ensures that proper permit coverage is established for stormwater discharges from wood waste recycling activities statewide at both MS4 owned and privately owned facilities. This wraps up the MS4 program overview. You can find the contact info for the MS4 unit on this slide. If you have any questions, please feel free to ask in the chat or unmute yourself. If there are any questions in the chat, we will look them over and respond as necessary. Up next is Lisa Schaefer. Thank you, everyone.
getting near the end of the program, but please don't leave just yet. So recently, the Bureau's web pages were updated, and we're not now all under one main page. So let's talk about the BMP manual and just click on the lighthouse. All right, so there's two different links to the BMP manual on the web page. For the 2023 rules, click on the top one by the number 1. For the rules in effect on January 20th of 2026, click on those by the number 2. All right, here are some screenshots from the updated BMP manual webpage. Everything that has been updated to this rule adoption has been marked as updated, as you can see here. A few more of the chapters from the updated BMP manual webpage, and please note that chapter 14 is new. At the bottom of the page are the sample MSWMP Municipal Stormwater Management Plan and Model SCO or Stormwater Control Ordinance for your use. The GI document that I mentioned earlier is at the bottom right. So the FAQs have also been updated. The new link is at the top of this slide. FAQs for older versions of the rule are near the top of the page, but to get to the 2026 rules, click on the link. All right, so make sure you're using the correct FAQs corresponding to the rules that are applicable to your project. Our BMP, on our BMP manual webpage, we also provided templates for the SCO for use by a municipality. The updates to the SCO align with the rule adoption and can be downloaded in Word or PDF formats. On the left is your screenshot from the updated webpage of all of the items available to download. There's a clean copy. Plus, there's also a strike-through version to illustrate where text has been removed, with the new text appearing there in red. And lastly, there's also a simplified version. This simplified version cites chapter and subchapter and section numbers from the rules instead of the full text to reduce or eliminate the need for the municipalities to revise their ordinance when the stormwater management rules are amended. Now, a municipality has to comply with the applicable laws and procedures for the passage and adoption of ordinances pursuant to the simplified version. All right, the MSWMP and SCO need to be revised and effective by January 29th, 2027 to conform with the amended rules. The location of the sample MSWMP was shown 2 slides ago on slide 18. On the lower part of this slide is a summary of the updates that were made to the SCO to match the rule adoption. Okay, moving on. So that is going to bring us to the closing information regarding the training. So the next course offering will be this fall, and you as a reviewer are covered for 5 years, provided you completed all 4 quizzes and, everything else there. You're encouraged in the interim to download. Hold on, let's see if it's going to work. Is it working? Nope. The slides for interim sessions of the training and view the videos before your certification expires. We want the website to be something that you go to, update your knowledge in between the times you have to take the training. All right. But please note that you can also use the pull down menu, and then you'll hover over the word training to get to the menu for the SWMDR and rule amendment training page. But please don't forget to check the webpage for updated chapters to the manual and other links for rainfall data and training periodically. Please check. So as we mentioned earlier, the email with the link for the course evaluation will go out soon, and we will need a response by the close of the business day on the date that we specify in the email. All right, we need the survey completed to receive either a certificate of course completion or a certificate issuing CPC credits. So if you review for an MS4 permittee, attend all 4 modules, complete all 4 quizzes, and are required to by the permit to complete this training every 5 years, you'll have to complete the survey before we send out the certificate of course completion. So likewise, if you're a professionally licensed engineer and you wish to receive a certificate issuing CPC credits, completion of the survey is a prerequisite to us issuing you any credits. And we will send out the certificates after we receive your course evaluation. We'll use your registration email for this mailing. So if your address changes, please notify us. And please use this email address. All right. So by the way, we will continue to use this account for future training and announcements. So make this one a trusted sender. And we ask this because so many emails to registrants, or rather to people who should be on the list, are returned. So if and when your email changes in the future, please notify us as soon as possible.